Hi everyone. Today we will be starting with disaster management and environmental planning framework for MPPSC. I'll just share my screen. Let me know if the screen is visible to you and let me know if my audio is clear. Okay, just give me a moment. Okay, please let me know in the chat if my audio is clear to you, if my screen is visible. Please let me know if my audio is clear so that we can proceed with the class. Okay, let me know if this syllabus is visible to you. If you can see the screen. Okay, so I'll explain what we will be covering through this subject. Basically, whatever ticks you are seeing, these are already being covered. And if you see some underline, that is remaining. This is because the syllabus was not out yet when we had covered all these topics. Okay, so for this disaster management framework and environmental planning framework, some of the things have already been covered, like your SDGs, types of disaster, vulnerability and risk, all these are covered. But there are some things like blue-green infrastructure networks, your resource efficiency, circular economy. So this comes under your environmental planning framework, which has not been covered, like climate responsive, urban planning, urban flood management strategies, resilient infrastructure planning. So this is particularly disaster. This is environmental planning framework. So these are not covered. And the last point, this one is not covered, which is disaster management strategies or structure in MP, risk governance and policy, and green building rating systems. Okay, so this entire point we will be covering, and the ones that I have underlined in this. Okay, so these we would be covering through disaster management and environmental planning frameworks. Okay, so currently 3 classes we have planned. If we feel like, okay, we would need more classes. So that would be scheduled upon seeing that. So currently we have 3 classes. I think it should be covered in 3 classes itself. So for today, we would be starting with environmental planning framework. So we would be covering topics like your blue-green infrastructure networks, resource efficiency, climate responsive urban planning, uh, green building rating systems. So we won't be touching upon disaster topics right now. We would be touching upon environmental planning topics, right, in this class. Okay, so we would be discussing resource efficiency, um, climate responsive, urban planning, green building rating systems, blue-green infrastructure networks. Okay, so these all we would be covering. This comes under your environmental planning frameworks. So for these particular classes, you'll have to maintain your running notes. I know for some classes, I prepare a presentation and I just give you the presentation. But for these topics, you'll have to maintain your running notes. Okay. Any doubt till here? Shall we start? 。 . 。 . 。 . 。 . 。 . 。 . 。 . . 。 . 。 . . 。 . 。 . . 。 . 。 . 。 . 。 . 。 。 . 。 。 . 。 。 . 。 。 . . 。
. . .
. 。 You don't need to write this down as this would come eventually in the class topics itself. Please be responsive in the class. Shall we start? Okay, please maintain the running notes for this class. I'll give you time to write as well, right? So firstly, we are starting with environmental planning frameworks. Um, you don't need to fall too much into the jargon of this, like this looks a little complicated. It's just that we are becoming familiar with some of the concepts that are used in environmental planning when we are taking environmental planning into account for our building systems as well as for urban planning. Okay, so since there is a newfound cognizance towards sustainability, there are different frameworks slash concepts that we use today. Okay, so we would be discussing those, whether in urban planning or in urban design or at building level. Okay, so since there is a cognizance for sustainability, that's why we have these new emerging concepts. Okay, so firstly we have resource efficiency. What do you think this means? Resource efficiency. What comes to your mind when we say resource efficiency? For anything we have to build or consume, we need resources, right? Being efficient about something means that in this particular context, that yes, how efficiently we use resources or how much we can reduce or minimize the wastage of resources or minimize the waste, right? So efficiency means that it is anything which is efficient, any process which is efficient is working at a very optimized capacity. Okay, so resources, we know that especially natural resources, economic resources, human resources are scarce. Okay, especially the natural resources. So how should we use them so as to minimize their wastage? Okay, so that is called resource efficiency. Okay, it is the idea of using resources in an optimized way or the most efficient way possible in a particular context. Okay, so we can write, so I'll write the technical definition as well. Resource efficiency is the idea of using natural, human, and economic resources in the most efficient way, such that it minimizes waste, energy use. So whatever energy we are inputting, if we could just reduce that energy usage as well, that would also come under your resource efficiency. And environmental impact. If we can reduce the overall environmental impact that our human practices are doing on the environment, then that is also a part of making the system efficient. So minimizing waste, energy, the overall energy usage, and the overall environmental impact. And environmental impact. Are you getting the definition? Is there any doubt in this? Also, let me know if you can't understand any word that I have written. I see like some new people have joined today. So let me know if there is any doubt. Please speak up. Like, let me know if there is any doubt in the class. Write in the chat. Okay. So note this down. Let me know when you're done. Economic resources would be like, let's say we say land or any capital. We say na land, labor, capital. So labor can come under human resources as well, but you need land for enterprise or you need some capital like machine, tools. So those are your nothing but economic assets, right? So these are the economic resources. Let me know if you've written it. Okay. Now, resource efficiency is considered to be a very important concept in your sustainable development. So we'll write that as well. It is an important concept in environmental science. And sustainable development. Are you aware of sustainable development goals? So how many sustainable development goals are there? We call them SDGs. I'll write it somewhere else. 17, right? In one of the previous lectures, we had discussed this. So to those of you who have joined newly, I'll show the sustainable development goals as well. So SDGs are very, very important from any paper point of view. Okay. So what is the target year for SDG? Does anybody know? Okay, so I'll just show you the goals. Okay. So these are the 17 sustainable development goals. Now, the thing that you should remember from an exam point of view, yeah, it's not 2050, it's 2030. Okay, yeah, remember this as well. SDG target year 2030. Okay. There are 17 Sustainable Development Goals. Who is it by? It's by UN or United Nations. Okay. Now, from the exam point of view, you need to remember all the Sustainable Development goals according to their number. Okay. So, for example, the sixth goal is clean water and sanitation, right? Then the 14th goal is life below water. Okay. Sometimes the question is like, which sustainable development goals are related to water, and then they'll give you options like SDG 2 and 3, SDG 6 and 14, SDG 15, or SDG 10 and 11. Okay, so they will just give you the number for identifying the sustainable development goal. That is why you need to remember the goal along with the keyword. Okay, and you should remember the keyword verbatim. Okay, so if it says zero hunger, remember it like that. Okay, so we'll just go through it quickly. So first is no poverty, then you have second zero hunger, third good health and well-being. Remembering all 17 sustainable development goals will also help you in a way that they give you an option which is not a sustainable development goal. Then you can easily identify that this thing is not being talked about in sustainable development goals, right? So you should remember all the 17 topics. So we have no poverty, zero hunger, third is good health and well-being, fourth is quality education, fifth, gender equality, sixth, clean water and sanitation, seventh, affordable and clean energy, eighth, decent work and economic growth, ninth, industry, innovation, and infrastructure. When you look at these goals, like when we talk about sustainability, we talk about it in three dimensions of what are the three dimensions? Can you tell? Environment, economy, and social aspects, right? So when you look at quality education or gender equality, you see that those social parts are being covered, right? When you see industry, innovation, and infrastructure, economic part is being covered, or decent work and economic growth, economy part is being covered. Life below water, life on land, climate action, you can see that environment aspect are being covered. Okay. Also, this means that industry, innovation, and infrastructure should be sustainable. It shouldn't be such that it is indiscriminatory on environment, right? So all these goals should come together. When you look at UN's site regarding the sustainable development goals, you'll also find different targets. Like this third point, SDG, you'll find a target like 3.1. There would be some target. 3.2, there would be another target. You don't need to go too much into detail of that, but these 17 goals you need to remember. Okay, so you need to remember these. Now 10th, you have reduced inequality. So it talks about social inequalities that are present in amongst different communities. Then you have sustainable cities and communities, responsible consumption and production. Okay, this also comes, this directly talks about your resource efficiency, right? Responsible consumption and production. Like today we see that with your fast fashion brands or very quick cycling of trends, we see that the consumption and production is not responsible, as many products ultimately go in the landfill, right? So that is not responsible consumption and production. Then you have climate action. Life below water talks about aquatic life, and then there's life on land. 16th is peace, justice, and strong institutions, and 17th is different organizations having partnership for attaining these 16 different goals. Okay, so remember all these goals. This is very, very important from exam point of view. Okay, not just MPPSC, any exam related to your architecture and planning, these are staple in any course. Okay, any doubt in this? Guys, let me know if you need any clarification. Okay, so make a note somewhere that you need to remember all these goals. Okay. Okay, coming back to your resource efficiency, which like resource efficiency would talk about your responsible production and consumption, industry innovation, and infrastructure, because innovation would lead to resource efficiency as well as economic growth. Okay, so these are invariably related to each other, right? Now, what does resource efficiency work upon? So, firstly, the key important aspects of resource efficiency. Firstly, there is a reduction in waste. Okay, so resource efficiency reduce the first goal here is to reduce waste. Okay, how can we basically reduce waste? We can use fewer raw materials, and we can just produce less waste. Okay, so using, and our processes should be evolved as such that it ultimately results in a reduction in waste. So there would be a sort of innovation required there. Okay, we can't rely on obsolete practices in any industry if we want to reduce waste. And whatever waste that is generated, if we can employ that waste into other useful um, processes, that is better than just getting that waste to landfill or some other area, right? So using fewer raw materials and producing. So this is one of the aspect, less waste. So this is one of the goal. Second, as I said, if we could just reuse, like employ waste for other processes, right? Other than this, it is very important in resource efficiency that the energy consumption is also at its most efficient. Okay, so there is efficient energy use. Okay, so which basically means lowering energy consumption for the same output. And if you can't lower the energy consumption, at least using renewable sources of energy or smart ways to produce that output. Okay. Note this down. Let me know when you're done. Okay. Next, you have sustainable production. So sustainable production means that designing processes over time that leads to your resource efficiency. Okay, it's not a matter of one or two production cycles that we are reducing our energy usage or our waste generation, but over the time we need to create frameworks and production processes which leads to an overall sustainability in the mechanism. Okay, so designing processes that conserve resources over time. Okay, so over a period of time. Lastly, we have uh, recycling and reusing. So this is basically keeping materials and tools in use and maintaining them instead of discarding them too early in their life cycle. So keeping materials in use instead of discarding them too early. Okay. So these are the four basic things that need to be kept in mind for your resource efficiency. Let me know when you're done writing them. Then we will discuss some of the key methods or frameworks, popular frameworks for your resource efficiency. Some of these you might have heard, some may be new for you as well. Okay. Are you done writing it? Okay, I'll just give a minute to others. Okay. So let's discuss some of the popular concepts that we see in this resource of efficiency. Okay. So we have certain popular frameworks or concepts that come under your resource efficiency for resource efficiency. Okay. Whenever we are talking about being eco-friendly or being sustainable, ultimately we are talking about resource efficiency only. There is some resource that is scarce and we need an efficient resource of, we need an efficient use of that resource instead of wasting that resource, right? So all these methods that we can use to minimize our waste, to minimize our energy consumption, those come under your common methods for resource efficiency. Okay. So firstly, we have something called, so this is obviously not an exhaustive list. I am telling you about some of the common popular methods. Okay. So firstly, we have something called lean manufacturing. Okay. This is a philosophy in industrial production. What do you think this would mean? Lean manufacturing. Any idea? Okay. Whenever you say lean word instead of in front of these kind of words, like whenever lean is used as an adjective here, lean basically would mean here as less. Okay. So lean manufacturing means that we have cut down any sort of overproduction, dead stock in the inventory, so any sort of excess inventory, because dead stock can ultimately lead to wastage, right? So lean manufacturing is a method or concept of production where we minimize our waste and maximize our value or maximize the value to the customer by reducing or avoiding overproduction or over processing of things. Okay, so that we don't have to deal with that overproduced inventory later. Okay, because that would ultimately lead to waste, not just that waste itself, but the waste of resources that we have used to make that product. Okay, so lean manufacturing is with whatever concepts that I'm discussing here, you just need to know the basics of these concepts because the basic definition could be written and it could be asked as an MCQ. So no need to go too much into the detail of this, but you should know what it means, right? So lean manufacturing is a production philosophy. So imagine an industry producing a product. Okay, imagine it in this way. Production philosophy focused on maximizing value and minimizing waste. Okay. Anything that does not add value is considered waste and should be reduced or eliminated. Now I talked about overproduction should be eliminated, but let's say there is a product in which you have introduced 4 layers of packaging. Sometimes we see in like chocolate bars or different kind of products that we buy that sometimes you also feel that, oh, this wrapper is unnecessary. There are 3 different wrappers. Okay, so lean manufacturing would be like whether this third wrapper or the in-between wrapper is even useful or not. Okay, more often than not, the answer would be no, it's not serving any practical purpose. So let's just remove it. Okay. So anything that does not add value, in this case, that wrapper is not adding a value, it would be considered a waste and should be eliminated. So what can be eliminated as waste has no place in lean manufacturing. Okay. So the product would have essentially maximized value and there should be less waste in the product itself as well. Okay. Now, the things that are eliminated are like overproduction. So keeping excess of product and excess inventory. Overprocessing. So overprocessing of goods that would lead to more usage of your resources, energy that is also not considered ideal in lean manufacturing is, and also defects. So if there would be defects, then you'll need to correct those defects and use more resources. Okay, so defects are eliminated from the start only so that the process should be efficient enough that no or very less defects are introduced in the product. Okay, otherwise you'll need to go through the process again. So in lean manufacturing, things like overproduction, excess inventory, defects, and overprocessing are avoided. Is this clear? Any doubt in this? Like, Okay, I'll just give a minute to others. Okay, next we have life cycle assessment. This you must have heard of in any kind of environmental impact study. We do life cycle assessment of material, right? So this is life cycle assessment, or sometimes it's like referred to as LCA. Remember the acronym also, it's life cycle assessment. In this, we see the life cycle, the entire life cycle of a product, right when it was a raw material, then the processing, then the transportation to its final place, then the usage of that material, and then ultimately the disposal of that material. So by assessing the environmental impact of that product's life cycle, we are able to identify the pitfalls in the whole cycle of that product and where we can save resources. So for example, life cycle of a brick would be something like extracting clay for the brick, then the manufacturing of brick, then transporting that brick to the building site. Then the usage would be the brick being used in the building, and after 50 years, let's say the building is demolished, then maybe the brick is being used elsewhere in another building, in some other place, or let's say the brick is being disposed of. So that just depends, right? So that would be the life cycle of a brick, and at each stage we are in a life cycle assessment, we are calculating the environmental impact of that particular brick. Okay, so life cycle assessment is a scientific method. Now, this is a method, an assessment method, right? So it doesn't lead to resource efficiency. It just helps us in identifying where resources are being wasted. So it is an analysis technique through which later on we can employ methods to conserve resources. Okay, it does not lead to resource efficiency, but it helps us in identifying. So this is a scientific method for measuring environmental impact throughout a product's life cycle. Okay. Now the life cycle would look something like raw material extraction, then manufacturing from the raw material, then transportation. So in transportation also energy is being used, right? So that is also calculated in LCA. Then the usage of the product or the use of the product. And then after usage, we ultimately the product is disposed of as a waste or maybe used somewhere else and then disposed of. Now this method, it is used to identify where the resources are being wasted the most. So when we study that, then maybe we'll be able to curb the wastage of the resources at those particular junctures. Okay, so this is life cycle assessment. Is this clear? To identify where the resources are being wasted the most. Where? Is it done? Okay. So this is an analysis method. Next, we have efficient energy efficiency management. Okay, so in this particular kind we are not focusing on let's say material waste and all, but since any kind of production cycles require energy, so the kind of energy that we use in those cycle is also important. Okay, so maintaining an efficient use of energy and not wastage of energy is a whole separate concept in itself, right? So this is a kind of method that are designed specifically for reducing energy usage, okay, and employing uh, innovative energy sources instead of using traditional energy sources which conserve natural which employ natural resources. Okay, so these are the methods designed specifically for reducing energy use. Okay. So examples could be like we could have LED lighting, could have solar panels which use sun as a source of energy. We can have efficient HVAC systems. Automation has played an important role in this. Let's say whenever there is nobody in the room, the light and fan automatically shut off. Okay, so that is also energy conservation. So that is also an energy efficiency management system. Okay, so there are innovative methods as well as traditional methods also, especially in building design, through which we can conserve energy usage. So, within your energy efficiency management, the examples would be innumerable. Let me know when you're done writing this. Okay. Uh, Next, we have material flow analysis, which just like your life cycle assessment, it is a method, analysis method, assessment method, and not a management and not a direct method of reducing resource. Okay, but it helps. So we have material flow analysis. Okay, so in any kind of production process, they track the uh, material flow through the system, the input of the material, the storage of the material, then the eventual wastage of the material. Now, with life cycle assessment, we are looking at one product's life cycle through not the manufacturing process, but through the raw material, then manufacturing, transportation, usage, and disposal. In material flow cycle analysis, we are looking at the whole uh, industrial manufacturing process, so to say. Okay, so material flow analysis tracks how materials move through systems. When we track this movement, we are able to capture the instances where waste is generated unnecessarily, okay, or where there is material wastage. So tracks how material move through the system. So that is input of material, storage, the output, the waste streams, okay. So this method helps you again see wherever material is getting wasted, and this is generally used by industries, okay, to make their production more efficient. So this method is used by governments and industries to optimize resource use. Okay. Is it done? Okay. Another method would involve your sustainable design. So, for example, construction is also a huge industry which requires a lot of raw material and resource usage, and not just during the construction phase itself, but also while people are living and operating in the buildings, right? So we have in this concept of resource efficiency, there is also green building design, as you must be aware of. So we have green building and sustainable design. Okay, so green building and sustainable design ultimately is such that it reduces the use of your energy, and there is an efficient use of construction materials as well, right? So this is basically, we will study this in detail through your green building rating systems, But for now, I will write it as efficient use of energy, energy during the site planning construction part, as well as during the operation of the building after construction. Water, because a lot of water is used in construction, and construction materials. Whenever we study green building rating system, when we look at the pointers through which the points through which they are the factors through which they are awarding the points, you'll see that these factors are being utilized, like energy, how water is being conserved, the construction practices, what are the materials being used. So these are the different factors on the basis of which any green building rating system will give you points. So, okay. Now, any sustainable design could also include you could just make a pointer of passive design techniques, okay, which are, can you give any example of a passive design techniques? And you have active design techniques as well. Any example of passive design techniques? Like having courtyards at in a hot and arid climate is passive design technique. Yeah, building envelope design, building orientation, thermal insulation are passive design techniques, right? Yes, building envelope design. What else? Yeah, sunshades. Yeah, fenestration, sunshades. Whereas, like any mechanical systems, like your usage of solar panels or any kind of smart building controls, which, as I said, like help you turn off the light when not in use. Those are active techniques. Yeah, wind tower is also a passive technique. Right? Then you have different building rating systems like your lead and rehab, which take into account whether you are using these techniques for your building or not, and they rate you accordingly. Okay, so that we will discuss later. So green building and sustainable design is also a resource efficiency management technique in your uh, building design per se. Okay, just give me a moment. Okay. So this was green building and sustainable design. Lastly, we have circular economy for your resource efficiency. So we have circular economy. Have you heard of this term? Any idea what it means? Okay, so let's say if I talk about linear economy, circular means that whatever processes are happening, it's happening in this circular way. Okay. Zero waste or less waste. Zero waste would be ideal, yes. So we have linear economy, let's say. In linear economy, what happens? You take raw material, okay? You make the product, you use the product, and then you dispose of the product. Okay, this is linear. It's just going in this direction. Now, in circular economy, what happens is that at the usage phase, before disposing of, we see that whether we can repair this product before disposing it off. Okay, whether we can reuse this. Okay, if not reuse, repair, whether we can recycle this. Okay, so it does not go into this dispose of phase. It just goes into repairing, making again, and then it results in this circular sort of flow chart. Okay, also other thing that could happen is, let's say this has become a waste. We look at the waste and we see whether it could be used as a raw material or any sort of material in for some other use in some other industry. Yes, one waste product to others raw materials. Yes, that could also happen. Okay, that would also be a part of circular economy, right? That in particular is called industrial symbiosis. So we'll write about this as well. So circular economy, we can say that a circular economy is an economic system designed to keep products, materials, and resources in use for as long as possible. Okay, so this would include your reduce, reuse, repair, remanufacture, recycle, all these concepts before ultimately disposing something off. Okay. Further, we can write the idea is to create a closed loop where materials continuously circulate. If not in the same cycle, they become part of another production cycle. Okay. Circulate instead of becoming a waste. Let me know when you have written it down. I'll give a minute to others. So basically, we can also use this one approach, which is called within the concept of circular economy. Somebody had said using one waste from one industry to another. It's called industrial symbiosis. Okay, so we within this concept we have industrial Symbiosis. For example, your fly ash waste is there. We can use it by making fly ash bricks and then using it in construction. Okay. So we have industrial symbiosis, which is basically waste of one industry can become raw material for another. Um, for industrial symbiosis, you can look up that there is this very famous project in Denmark. It's called a circular economy or symbiosis project at Kalundborg, Denmark. Okay, it's a very good example of uh, industrial symbiosis. You can look up this example. It's the most famous example given for industrial symbiosis. Okay, so this was about resource efficiency, different methods that are used within your resource efficiency. You need to understand the concepts of the different frameworks that I've described. Next, we'll be starting with climate responsive urban planning. But before that, let's take a 2-3 minute break and then we will resume. Okay. Let me know for the timing, let me know if there's any doubt in what we have discussed so far. Okay, so let's start with our next topic, which is climate responsive urban planning. We basically know about this climate responsive architecture in which we work on building level to make it more responsive towards local climatic condition, as well as having reduced impact on environment. Okay, so just think of that not on a building level but on an urban planning scale. Okay, so we have climate responsive urban planning. Okay, so whatever, let's say in for your building you see one building's orientation. Okay, whereas in your urban planning we would see the entire street's orientation, like that. So the scale would increase. Obviously we would look at systems, we would look at effects like, let's say, your urban heat island effect, right? So how to reduce that or how to eliminate that altogether if we can. So those are the things that are tackled on a planning scale, if not on a neighborhood scale, on a planning scale. And that's why we are saying climate responsive urban planning is also essential. Just give me a moment. Just hold on. Yes, this is the one I was talking about, Kaldenberg. Yeah, you can look it up. Maybe you'll find some presentations, different things on this. This is the most famous example that is given for industrial symbiosis. Okay, let me know if the screen is visible. Yeah, if you like study that a little bit, you'll understand how different processes work. Okay, so we were at climate responsive urban planning. So we can say it is an approach. Again, we need to reduce environmental impact. We need to uh, be cognizant of the local climatic conditions so as to improve our own human comfort, right? So taking everything from the building level to, let's say, urban planning level. So but with climate responsive urban planning, there's also this added dimension of reducing the risk of any sort of disaster like urban floods, etc. Okay. We do not talk about that on building level, but on urban planning level, that is also essential. So it is an approach of designing cities and urban areas in ways that respond to local climatic conditions while reducing environmental impacts and improving human comfort and sustainability. Okay, so this includes several dimensions. We'll discuss those one by one. Again, not an exhaustive list, but basically it has different aspects to it, and we'll discuss those. Let me know when you're done writing till here. Okay, so this can again have several dimensions. So firstly, for your climatic aspect or local climatic aspect, we can have passive climate design. Okay, so this would include having urban layouts in such form that it resonates with the local climatic conditions. So urban layouts and buildings are designed to naturally regulate temperature and airflow. Okay. So this is obviously about, you can also say here we are looking at what should be the building orientations or rather street orientation, right? We look at shading systems, width of streets, natural ventilation, how that would happen in the region. So from this point, we can also have another point, which is basically your local climate adaptation. Now, this would be both on your building level as well as wherever it is possible on the level of urban or neighborhood scale. So, for let's say if you have hot and arid climate, you require elements like shade, courtyard, narrow streets. Okay. If the streets are wider and the building scale not that high, you'll see that there would be a lot of heat and lot of sunlight directly on the street. It would make it difficult for people to go about their day, right? Then you have cold climate for which we, on the neighborhood level and on the building level, we want to increase solar heat gain. We need to maintain compact urban forms so that there is solar heat gain, right? Then for, let's say, your hot and humid climate, we require a lot of ventilation and airflow. So the building orientation, the street orientation, etc., should be such that it facilitates ventilation. Okay, so all these things should be kept in mind, not just for building level design, but before that also it should be kept in mind during the urban planning process itself, or at least during the neighborhood planning process itself, right? Let me know when you've written it. Is it done? Okay. Next, you must have heard of, like, since we're talking about climate responsive planning, uh, you must have heard of something called urban heat island, or UHI. Remember the acronym also, you can get, they could just give you the acronym and ask for the full form. These are also very common kind of questions that you see in state examinations. Okay. So what is urban heat island? Any idea? Just look at the terms and try to deduce what heat trapped in urban streets. Okay. Yeah. So what happens is, let's say, consider this area. Like, let's say this is an urban area. Okay. With streets, asphalt streets, right? Concrete. It's a concrete jungle. Okay. Nearby, you have suburban areas. You have some suburban areas, followed by some forest. Okay. What is discovered is these areas, these urban areas tend to be hotter than these areas. Okay. And why is this happening? Because these areas contain more materials like concrete, asphalt, which are not naturally cooling, but they tend to absorb heat in these like urban streets and these built forms, right? So one of the aspect of climate responsive urban planning is also to reduce this urban heat island effect. Okay. If you see in, let's say, Delhi, it happens a lot. Okay. If you go out in a street in Delhi in the middle of the day at 2 p.m. in May or June, you would feel this effect as compared to if you are in a smaller town. Okay. With similar, and this effect you can feel even if the temperatures are a bit same. Okay. You can feel the urban heat in these urban areas. Okay. So one of the goals of this responsive planning is to also reduce this urban heat island effect. So we can write urban heat island reduction. Okay. We say that cities have become hotter than nearby suburban areas, suburban or even village areas due to the usage of concrete, asphalt, etc. Okay. Now to reduce this, basically what is happening? Heat is coming here on these kind of materials, these hard materials, and getting trapped. Okay. This effect could be reduced through, like when we see a forest, we see a lot of trees there. So we naturally know that green roofs or planting more trees can actually help reduce this effect. Or um, basically, treating the surfaces with green material can help reduce with urban heat island effect. And there should be a substantial use of this use of grass and green material to actually have a considerable reduction in the urban heat island effect. Okay. So to reduce this effect, we can reduce this effect through the use of green roofs, parks, urban forests. Okay. What do you think we can collectively call them? These three things that I have named here. What are these a part of? I'm looking for an answer like what I'm going to discuss later. A term. Not local architecture. This is green infrastructure. You've heard of blue-green infrastructure? So this is that green part of that blue-green infrastructure. Okay. Write this down. Let me know when you're done. Yeah, green strategies. Okay. Let me know when you're done writing this. Let me know if there's any doubt in this urban heat island reduction. We commonly say UHI also. Okay. Okay, I'll just give a minute to others. Okay, then we have water sensitive urban design. Okay, or basically when we are talking about urban design, we are talking about let's say a neighborhood level. So we have, but it is referred to as water sensitive urban design. Okay. You can also abbreviate this WSUD. Again, this is an urban planning approach through which there are certain things related to water that we want to improve, like to reduce your flooding and stormwater runoff, to conserve water in urban areas, to enhance groundwater recharge. Okay. So, water sensitive urban design is an urban planning and design approach that aims at managing the urban water cycle sustainably. Okay. Uh, the usual things we see in this are, okay, first write it down, then I will write down further. Is it done? Okay. So what are the general aims of water sensitive urban design? Reduce flooding or stormwater runoff, right? Um, Conserve and reuse water, Okay. Enhance groundwater recharge. Improve water quality. So most of the urban water related problems it aims to tackle. And if you see the elements that would help in doing this would be rainwater harvesting systems or bioswales or even green roofs or any green material, stormwater detention ponds. So all those infrastructure come under your blue infrastructure. Okay. So when we will discuss blue-green infrastructure, you'll see that blue-green infrastructure ultimately helps in your water-sensitive urban design as well as in reduction in your urban heat island also. Okay. So urban heat island part is seen by your particularly green infrastructure, and this water sensitive design is seen by your blue infrastructure. Okay. Make a note also in this that yes, I'm making a note in this. BGI, like bioswales. We'll discuss this later. Bioswales, green roofs, urban ponds, storm water systems are considered important tools for WSUD, water sensitive urban design. Also write permeable pavements. There are numerous examples. Have you noted it? Okay. So in your climate responsive urban planning, firstly, we are seeing that we should be in resonance with the local climate for uh, human thermal comfort. Then we need to see that urban heat island is reduced. Then there should be water management efficiency. So there should be your water sensitive urban design. We have certain elements for that to reduce stormwater runoff, conserve water, in general, enhance groundwater recharge. So for your UHI as well as for your water sensitive urban design, we can incorporate certain blue green infrastructure elements to help with that. Okay. Other than this, there has to be a climate resilience in general as well in any city, because any city may be subjected to or prone to certain kinds of disasters. Okay. So for that, climate resilience, not just adaptation to local climate, but climate resilience is also very important. Okay. So the next point is, it's the fourth point, but I just made a bullet. So you have climate resilience. Okay. So that could help with any local disaster. Okay, so urban systems should be designed for your urban flooding, or let's say if the city is near a coast, so there should be coastal protection. Okay, so climate resilience, I'm just going to write some example that urban systems designed to reduce climate risks like floods, heat waves, coastal sea level rise. Okay, so the responsiveness towards this would be, examples could be, let's say if there is a problem of sea level rise, we could have elevated infrastructure at these vulnerable places. Okay, we could have other coastal protection strategies. So that would also include whatever rules and regulations that apply in coastal regulation zones, basically. So coastal protection. Then for your urban flooding, there should be proper emergency drainage systems. So different kind of resilience, or like different kind of strategies is needed for different kind of climatic risks. Okay. So emergency drainage systems. So these are just some examples. Any doubt in this? And in general, also for your climate resilience, it is important that you do not build in any known vulnerable area. Like, you know that this is a low-lying flooding area, so you won't build uh, infrastructure there. Okay, so it's very important to actually consider risks before developing as well. Let me know when you've written it down. Are you done writing it? Okay, so like I said, um, along with climate resilience, we also need to be very aware of where we are developing. Okay, so that's where land use planning comes in. So we have land use planning, a part of which is to avoid building or developing in environmentally risky areas. Okay, avoiding environmentally risky areas for development. Okay, and this would also include, like when we are talking about environment, when we are looking at development, we also, this is on the cognizance of the local development authority to see that this kind of development does not happen. Or if there is a large project which is environmentally impacting some area and creating a risk. Okay, so an EIA for that may be done. But basically, when we are calling an area an environmentally risky area, let's say if it is on a plain, something like that, then the it is upon the local authority and the people to take cognizance on that, right? So examples here would be not building on floodplains, protecting wetlands, okay, conserving urban forests. So it's not just about the risk only, but also what kind of environmental impact um, may happen if we do any planning, any development there. So let's say a big project is proposed on an urban forest. Okay. So for that, an environmental impact assessment has to be done to see whether the project is even worth it or not in terms of social, environmental, as well as economic aspects. Okay. So that is also needed in your responsive urban planning. Let me know when you're done writing it, and then we are just left with one point. Okay. Lastly, we have, since we are talking about um, climate responsive urban planning, we and transportation is such a big aspect of a city. It's a skeleton, it's a network within the city. Sustainable transportation has also become very, very important today, uh, because the firstly due to environment, secondly because the motorization rate has increased so much in Indian cities that uh, by cars there is a lot of congestion on roads and people are not able to get across in major Indian cities, right? So because of that, public transit has become very important. So within public transit there is your BRTS, which is basically your bus rapid transit system. There is metro, so which comes under your MRTS. So these systems are basically capable of transporting a large amount of people at once from one place to another, as opposed to, let's say, a car or a two-wheeler. Okay, so public transit has become important not just in sustainable mobility, ultimately in sustainable mobility, but also in its efficiency, right? So there's public transit. Then, talking more towards the environmental aspect, we have cycling. So cycling infrastructure, is important during urban planning, um, as well as pedestrian friendly streets. Okay, because of your public transit, last mile connectivity is very important. Okay, if there is public transit, it's not like they're dropping you off at your home, right? And let's say you want to walk 500 meters, so for that, the street should be safe for you, right? So there should be pedestrian friendly streets. And of course, we have the concept of TOD. Can anybody tell me the full form? What is TOD? Not transit oriented design, it's transit oriented development. Okay, transit oriented development. Okay, which incorporates all these elements basically. So transit oriented development is a high density mixed use development which results in compact city formation at major transit corridors, and it ensures last mile connectivity. Okay, so the development is such that people from offices travel to their home through these transit corridors and vice versa while having last mile connectivity. Also, due to these transit stations present at these areas, the land value for the areas of residential areas and the office areas also increases. So it's like a self-fulfilling prophecy where the mixed use development is benefiting from the transit stations that are available there, and transit stations are used by people because there is high density development in the area. Okay, so it results in a compact city rather than urban sprawl. Okay, so it ultimately helps us in sustainability and more efficiency within the city's processes. Any doubt in this? Okay, so these are the different dimensions of uh, climate responsive urban planning. We'll stop the lecture here for today, and then in tomorrow's lecture, we'll start with I'll start with a little bit about this blue-green infrastructure. You already got to know about this in your climate responsive planning, but we'll discuss this in bit of a detail. Then we'll move on to green building rating systems. Okay, so we'll move on to that building level. Any doubt from today's class? Anything from your side? Okay, so are you guys done writing? Can I stop sharing the screen? Okay. Okay, so we have a class tomorrow. Okay, so we'll continue this. Okay, thank you.